Hello, my friends, welcome to Incidental to the current channel. This is Uncle Misha, and today we have yet another device I have found in Value Village thrift store. So, mosquito situation is in our area is pretty bad. And I didn't bother buying any kind of chemical thingies and devices which are, for example, in Costco, which actually zap bugs, so because they are expensive. Found this one in Value Village and decided to give it a try. So what it is, this is thingy which has some kind of black light in there, as you see this. It's powered by this little teeny tiny 12-volt power supply, and it has fan and a container. So how it works, I think the principle is like this. This light emits something that attracts bugs. Bugs kind of fly in, get sucked in by the fan, and being entrapped in this thing because fan is constantly working. Then if you do something like this, you can shut it off. Bugs still won't be able to get out and gonna eventually die in there. I guess that's the idea. So I was running it in overnight once, and actually I got some bugs. Not many, but to be honest, like a lot of mosquitoes. Yeah, so I'm actually pretty, it's not like it's crazy amount of bugs for like 24 hours operation, but I think this is pretty decent. Yeah, some of them are moth, but still plenty mosquitoes. Yeah, a little bit gross looking. Yeah, but I think it does the job. I thought it's not gonna do anything, but it actually does the job. Obviously, it catches the bugs which are completely harmful, and unfortunately, but it also catches mosquitoes. There is like several, probably 3 or 4 different kinds of moth here. So there is a fan. While this thing is operating, probably no bug can get out, and fan is greeny yellow. Greeny yellow, what a creative name. Greeny yellow DC brushless fan, 12 volt, 0.180 milliamps. Made in China, obviously. Foshan green yellow electric technology. That's a serious business. Anyways, my idea today is to poke Dynatrap. Oh, I didn't know it has a name. So my idea today is to actually poke around and understand how this thing works. I'm kind of wondering, is this like LED thingy? Otherwise, in this case, it's going to be very simple. Or this is actually a proper red black light CFL. In this case, inside has to be some sort of CFL driver. So they're gonna figure this out. But because CFL driver won't be able to run from 12 volt without any kind of voltage boosting, so it's kind of interesting to see what's inside. So let's stick around and let's pop this guy open. Okay, so I don't know how to open this thing. The only screws I have access to are these two. One is just right here. Alright. Another is right here. Yeah, so you see this little screw right there. Well, I need to separate top from the bottom, and it's there are more, and I just don't see them. More screws, no. Okay, it's going to be puzzling. How do you open up Sesame? It looks like this guy has clips. Nothing these days comes without. It's just as easy as this. Okay, so we have a grill, we have a fan, which covered some kind of bag splats, but that's to be expected. Okay, now here is more. So this is how it looks like inside. So there is obviously 2 wires for DC brushless, and here is the light. And now I'm curious, what kind of lights? Screws are pretty tight. What kind of screws are these? They're very strippable. Very. Wow. Okay. Only 2 screws. What the hell? More clips? No, it's just like this. Oh my god! Oh my god! What I see! Okay, that's not gonna pop because they glued it. Let me unglued it. Okay. Okay, so turned out to be this is for real high voltage shit. Because take a look at that. They have high voltage transformer. Yeah. So fan is always on. It just goes probably straight from the power supply. But over here, I'm curious what kind of voltage is here. We have high voltage tranny. Okay, this is supply, this is transformer, here is high voltage. Curious. What do we have? The schematic's probably very simple. Let me kind of pull this out. It's not gonna power it up, I think. Maybe I will. This thing was actually once under the rain, so I'm not sure how that's gonna... Okay, nothing on the back side. Looks like this thing is made in, attention, 2004. 21/01/2004. It's pretty old. And there is a capacitor here. Interesting, what kind of voltage? What's the capacity of this flick? I'm curious. Okay, we will check that later. Very interesting. Okay, so we have 2 transistors. Let me see, this is our... Yeah, unfortunately I can't really pull that side out that easy. Not even screwed, it's like glued. Yep. Even if I pull this green one separate from the black one, it's not gonna solve much. Not gonna help me much anyways. Okay. I wanted to check the transistors. If they are just forming just simple oscillator. Transistors are D1616A. What's the other guy? D1616A. So yeah, we have an inductor, a capacitor, an oscillator, and 2 resistors. Okay. A little bit corrosion good, or maybe some water got in here actually. And there are 6, 1, 2, 3, 4, 5, 6. 6 pins. Let me zoom in. Okay, this is a bit better. So we have this oscillator and 6 pins of the transformer and 2 pins out. So this is the primary side of it, and looks like we have... Interesting, why we have it such a... I thought it's gonna be at least 4, not 6, because like 4 each, how to say, we can drive one or another, one another, and here is going to be formed this sinusoidal, because obviously this is going to be sinusoidal signal here because there is no rectification on this side. Okay, but looks like it's 6. Let me think about it. Why do we need 6? So clearly there is an oscillator here, but why do we need 6? Well, technically it's 5, right? Because looks like the let me actually buzz this. I'm just curious how do they connect it? Okay, guys, after doing some sort of poking around and figuring out how this stuff works, I couldn't really do it without desoldering the transformer. So I pulled out this transformer just because I need to understand what are these 6 pins are. Obviously this is output and this one is here. So this is how it looks like. So essentially we have 3 sets of windings. So one windings is like this, and 2 other like essentially we have 3 windings. So let's look at the schematic. So one of them is feedback, another is I think this one is feedback. This one is one half wave, another is like another half wave. So what do we have here? We have saturation oscillator arrangement of those 2 transistors, which are, well, according to the spec, they are KSD1616A, and here is some sheets, spec sheet on Mauser. I'm not sure if this is specifically Fairchild, but it's KSD1616A. There is a whole bunch of Chinese clones of this stuff. So this is audio frequency, power amplifier, and medium speed switching. So this is clearly medium speed switching scenario. So I'm not sure what kind of frequency we're talking here, because I need to power this all jazz up, return the transformer back on, and try not to kill myself with high voltage. So we have here 2 transistors, which are each of them connected to each individual winding of the transformer, and there is, I believe, this one is this a feedback sort of transformer. So this guy feeds into bases of these transistors and open them depending on the how to say, polarity, let's say, of the voltage applied, of the polarity of the current. So these they're going to be open alternatively. So essentially, well, this all starts, one of the transistors opened faster than another one and started charging, how to say, putting energy into this coil. Then when it's completely saturated, it's gonna pull it here, and then it's gonna drop, and then another this start discharging and another start charging, and vice versa. So it's essentially one transistor, another transistor, another one. So you're gonna how to say, so essentially it's gonna work one or another. Like, I think it's like a push-pull configuration. I'm not sure how, if it's called this way, but obviously this is gonna work as inverter because it's gonna produce sinusoidal signal from the DC signal, which is going to be in this case 12 volt. So yeah, and on other side we have output winding, which gonna be high voltage. So this, for example, winding is gonna have, I don't know how many turns, let's say 10, and this is gonna have something like 160, 200, somewhere in that range. So I have no idea how exactly, what exact arrangement right here, but yeah. So over here we have a 3 kilovolt a capacitor. So yeah, I'm not sure if this is actually running at 3 kilovolt. I don't think so, but we can have some quite high voltage here. I'm not sure if I have anything to measure voltage like that, so I'll think about if we're gonna try to measure it or not, so if I would be able to. So now probably gonna put it all together and try to measure some frequencies, switching frequencies with oscilloscope, and I don't know, somehow try to measure the voltage on output. Another thing, I'm not sure if you have to have load actually or not, because it may not work without load properly, or actually get into saturation and then just blow up because there is no way to release this energy anywhere. So this is another important factor. So probably would have to actually attach the high voltage light bulb in order this thing to work and not to blow up. So now I have to resolder this stuff. I'm gonna do this with camera. It's just like this, goes just like this. Again, this desoldering gun made a very easy job of actually pulling all this this transformer out. So I'm gonna put this back on. I'll try to measure first of all switching frequencies and the voltage here at the output. Okay, so we have it working. So, and I don't know if you see, but this little thingy, probably not the best way of poking around, is lit with some kind of barely visible light. and fan is operating. So now let me somehow see, let me think first, to understand at what frequencies this thing operates. Let me shut it down first and prepare oscilloscope. So alright, so here we are. I'm measuring with my oscilloscope. It's set to 1x probe. And let me poke. So we're gonna connect it to the center point to this center point. Essentially measure across this coil measure across this coil, for example. Okay. It shouldn't be too high of a voltage here. And I'm getting 39 kilohertz and 13 volt RMS, 36.8 peak to peak. Okay, so 40 kilohertz, that's actually what expected. I did it's a medium frequency switching thing. So now it's very interesting thing how to measure high voltage. Let me try something here. Let me prepare it first. Gonna shut this down and think. Okay, I think I won't be able to continue, unfortunately, because I do have this old Simpson multimeter or ammeter, which I was given actually for free, and I thought it's operational, but turned out to be it is not. So I tried to measure it's just battery voltage right now just to test it, and it's not working. So the reason I kind of tried to look into it, because this guy has 8,000 volt range, and also it has 5,000 volt range. So yes, so this is cool device. Again, I haven't used it before. It was just sitting collecting dust on my bench because I didn't get my hands on it, and won't be able to actually do it yet. So essentially I won't be able to continue with this to measure voltage because I don't have a tool to measure voltage. So I have fluke multimeter, but the top range of this guy is 1000 volt. I'm pretty sure this is more. If you have 13 RMS input, and as far as I understand, the difference between coils is like 1 to like 20, so you're gonna get few kilovolts on output. So I'm kind of afraid to. I'm not even sure what's gonna happen. So I'm gonna risk my favorite multimeter on that. So this guy, on the other hand, if it would be working, would be fine to try because it has range of 5,000 volt. Even you see there is a two contact AC/DC 5,000 volts, so that's kind of cool. Again, I haven't even read the specs of this guy and see how it's all done inside, if it's properly insulated and things like that. I didn't even ever open it. I haven't even tried. So after I got it, I just plop it on the bench, on the shelf, and I was just sitting there collecting a little bit of dust. It's not much really. Anyways, so I think we kind of figured it out. I'm gonna shut it down, not to hurt myself. So we figured out the schematic of this guy. All right. So it's like, I hope you see it. The schematic of this guy. Okay, how it operates, the oscillator, and we figure out the voltages on inputs, but I don't know the voltages on outputs. I believe they are in the range of 1.5, maybe 2 kilovolts. That's why I have 3 kilovolt capacitor right there, so it has to be properly rated. So I think at this point we have to wait for a proper tool which wouldn't be able to measure this voltage. I won't be able to actually figure out the output voltage without knowing the the exact number of windings on that transformer. But nevertheless, I think we did fulfill our curiosity and to understand how this thing works, and it's certainly a. Oh, actually, sorry. One thing I didn't take a picture. So underneath of this transformer was such as the following text. It says GM906 P01 AMH, but then it says 2020 821. So this is kind of confusing because in the bottom it mentioned 2020 821, so like August 21, I assume, but over here it says 210104, unless they're talking about 2021-0104. I have no idea. Either it's 21st January 2004, or this is like I don't know, for 04 stands. Or the 4th January 4th 2021. Like, this is like, pff, you guess as good as mine. This thing can be like either either from one. Let me see also, maybe there's no. What I can do, I actually can go and check for Dynatrap. I try to read here, maybe there is yeah, 2020. Okay. So yeah, okay, never mind. So this thing is not from 2004. Over here in some kind of caution kind of text, they actually mention 2020.2. So yeah, this thing is from like not distant past. Okay, well, that's good to hear. It's not that crazy old, but I'm telling you, it's so simple. It can be as old as like 30 years old. It's nothing here at all. Like, it's completely nothing here. And CFLs were they were manufacturing CFLs like probably in I don't know, 70s or 80s or something. Yeah. Okay, so we're gonna put it together and actually conclude the video. Okay, so we put it together, it's operational, it's gonna go back in the garden, on the backyard, and actually start catching more bugs. But today, actually, I think we fulfill our general curiosity to understand how this Dynatrap not zapping, so this is not zapping, it's a trap. Dynatrap trap works. So yeah, we know it uses high voltage stuff. It uses the fan to suck the bugs in and capture them here. And now we understand. I'm gonna a little bit redraw maybe the schematic a little bit better, you know, to share with you. And I'm gonna put this on my website for you to take a look. Maybe I made a mistake or something. You can correct me and things like that. Yeah, I think this video is successful, and if you want to know more and you want to see more videos, please subscribe to my channel, follow, like, comment if you want to my content go to the top. For example, if you want to see a future video of how I repair and look inside of this beautiful old piece, Simpson 260, actually I think made in Canada, multimeter or ammeter, please, please subscribe. Definitely it's coming down the pipe. And stay tuned, stay safe, and ciao.